What's going on, guys? Johnny Bannon here with Trepa Technologies. Please feel free to like, subscribe, share with your friends as we finish up Domain 2 of our Network Plus N10-009 free video series. Finishing up Domain 2 by going over cabling, some physical things that would be done in our comms closets or our data centers. So let's go ahead and jump right into it. Zoom my face out, and let's take a look at our objectives. So first, we're going to go over important installation implications. So where we're going to put our patch panels are distribution frames, different rack sizing, different cabling panels we have. Then we're going to get into power and environmental factors. This is going to be one of those slides where not much I can put on the whiteboard. We're just going to have to get through the content, okay? So first thing we're going to talk about is an IDF and an MDF. This is going to be where we put our equipment, maybe in a campus network, or where our patch panels are going to be, okay? So an IDF. An IDF is a smaller network closet or room that houses the networking equipment, such as switches. There's going to be an ups there probably, and it's going to act as an intermediary between our user devices and the MDF. Think of like you're a network engineer, big office building, 20 floors. Maybe the data center is like on the first floor, second floor, wherever your data center is going to be. Probably on the first floor, right? And every floor, you're going to have 20 to 40, 40 to 60 users on every floor, maybe just depending. Where you're probably going to have a few comms closets there, and in those comms closets, it's going to be a couple switches, ups, and patch panels. That's the IDF, okay? And then that IDF is going to serve that single floor, and then have probably like a single mode fiber connection, like 10 gigabit fiber connection, down to the MDF, the main distribution frame, which is maybe just going to be a big patch panel that then connects to a couple distro or core switches. Kind of the backbone that may be located in the data center. Maybe it's not. Maybe it's located in a bigger comms closet. And then we have 40 gig out to like our core or our WAN, our ASR router or some big beefy router, big beefy core switches, okay? That's the best way I can explain an IDF. There could be other things in there, room for other things in there as well, right? Maybe if we want more than just switches in there. That's typically what you're going to see. Then the MDF, the main distribution frame. This is the central point of control for network connections in a building. It is where external network connections, such as the WAN, terminate as well. So this is typically going to be where your ISP comes in. So when the big ISP comes in, maybe you have two business ISP connections, you're bringing them to their MDF. Or you're bringing them to your MDF, right? It's typically strategically located, typically near the building's incoming telecommunications line. So yeah, whatever circuit you're connecting off to, maybe that's where it's going to be, or maybe that is the data center, right? So just a quick example of what this looks like. If we look at a network diagram, like a logical one, you can see the IDF is maybe, we have a beefy switches there and then a couple access switches throughout it, or maybe it's just access switches in the IDF. There's not like a one size fits all for the network. Really, it just kind of describes like, oh, we got equipment here. That's an IDF. If it's not the main one, it's an IDF. Now, an IDF could have distro switches, could have a lot more network equipment than maybe the other IDF on another floor. Okay, so it just depends. Okay, now something that we're going to talk about that when I first got in to IT, working the help desk, that you really don't learn about. I didn't go to college to get into IT, right? I did it in the military, and this wasn't really explained to me in my initial training. And then when I got into data center builds, I had to learn on the job the different sizes and how you can order rack sizes, and the width, the U is always going to typically be the same. When you say U, like a 1U router, that means it's going to take up one slot in that rack. But depth matters a lot depending on you're putting servers or network or what type of switches, distro switches, okay? So network equipment such as switches, servers, and routers are typically mounted in racks, data center racks, to organize the hardware efficiently. They're measured in U's, so units, where 1 U is 1.75 inches in height. That's like just, I think of it like columns, right? That's your column. So if a server, a big beefy server is 4 U, that's a big server, right? Actually, let me pause the video real quick and I'll show you what I have in my office here. I got a little Ubiquiti rack. So you can see here, I got my Ubiquiti rack here. So this is a 1U size. So you can see here we have 1, 2, 3, 4, 5, 6. It's a 9300 Catalyst, 48 port switch. This is my Ubiquiti Dream Machine Pro. Look in the back here, you can see the depth size difference. So my Catalyst there requires more power, bigger depth, and my Dream Machine Pro, my daughter had some Expo marker on that, so ignore that. You can see the different range just here, even with a typical Axis switch. So if we had some servers here, some Power Edge servers, we would need a lot more depth for our small office little environment here. Okay, so back to it now. So it matters, right? I don't know if you saw there. Go look at the footage here. I'm on OBS. Anyways, so the depth and what you're buying matters for the equipment you need, right? Big data center builds, those big racks like we see right here in my mouse is, typically the depth is going to fit all servers, your storage area networks, things like that. But if you just got a small office, your house, maybe the depth, you just need switches. You're going to have a NAS there and switches and a router. You don't need something as deep. Okay, the port side exhaust. So data centers are built with the exhaust in mind. And what I mean by that, when we get into, this kind of gets into the environmental controls, is that a data center is going to have what's called hot and cold aisles, okay? Because this equipment gets so hot, right, we don't want it contrasting. We don't want a switch here with the exhaust going this way, and then a router here with the exhaust going this way. We typically want it uniform. So we want to create what's called hot and cold aisles. So network devices typically have fans that intake cool air from one side and exhaust hot air from another. So we want to orient them all the same way. And what happens is in our data centers and our comms closets, we get a cold side, and we get a hot side, or a cold aisle and a hot aisle. Okay, so cabling. So proper cabling. So we're going to have something called patch panels and then fiber distribution panels. Now on the job, if you're just like, hey, let's take a look at that patch panel and it's fiber, depending who you're talking to, you may have to tell them this is a fiber distribution panel. It does matter, right? But a patch panel just at the base is where if I have a switch and I have a patch panel, that's where I connect from my switch to the patch panel and then out the patch to wherever that may go, okay? So the purpose, patch panels keep cables organized and ensure that ports are easily accessible for connecting devices to the network. They often sit on top of the rack, or maybe like I've even seen them in the middle sometimes of racks. I don't like that. But yeah, typically they sit on top of a rack, okay? What's cool about these patch panels is if that you're organized, you can have a little marker and you can label it. You may not have to do like little tape around your cables when you're using patch panels, okay? The patch panel may correlate, that number on the patch panel may correlate to also the wall connection, right? So you may have a comms closet that's serving 6 different rooms. So you go to that room, you look at the wall jack and say, okay, that wall jack says 1U-2-22. You come back to your patch panel, and if it's labeled correctly, you say, okay, where's 1U-22? Oh, right here. Well, there's no cable from the patch panel to my switch. That's why that user, nothing's working, right? And you put your patch cable, which maybe is like 1, 2, 3, 4, 5 feet, okay? Then a fiber distribution panel. So the fiber distribution panel is similar to a patch panel, but it's specifically designed for managing fiber optic connections. And you know with fiber, we have so many different connector types. So a fiber distribution panel is essential that there's uniformity and that there's good planning in place. But also fiber is delicate, right? So we want to make sure that there's minimal bending of the fiber cables in our fiber distribution panel. Okay, just something real quick. We may want lockable racks. If we have a rack that may be, like I see this at grocery stores a lot. They'll be like on the wall, you know. We want to lock it. If somebody can get to our rack, we always want to lock it. And even if that rack is in a comms closet that only the IT team is supposed to have access to, we want it to be locked just in case. It's just good physical access control and good physical security. Okay, power considerations. So in our data center, we want to make sure that we have redundant power. We want something called an UPS, that's our battery backup. We may want a generator with an automatic transfer switch. But at the base level, we want an UPS, okay? So an UPS provides backup power in case of a power outage from maybe 15, 30 minutes to an hour, 2, 4 hours. We have UPS that are rated and graded for different things. A data center UPS may be as big as the whole rack. You could have an UPS in every single individual rack that maybe is the size of a server. Or you could have a simple APC one like we see right here that may be just for your house or your small office. I have one that looks very similar for my equipment here that just sits on the floor. power distribution unit. So in our big data center racks, we're going to have PDUs. As you can see here, these are cables that are specific, right? These are specific cables that you're going to have in your data center rack. Now, the purpose, though, of a PDU is really just power management. It's just going to provide multiple outlets. It can also monitor power usage on the device, depending how advanced or if it comes with any features, right? So we have basic PDUs that distribute power, while more advanced models allow for remote management and power usage monitoring, which is pretty cool, right? That we could get that out of just it just looks like a normal storage protector. We can actually get some advanced things for our data center. Okay, environmental factors. So there's a lot of environmental factors that go into data center builds and managing a data center that we have to be aware of as a network engineer, network admin, even if we're not the people installing HVAC, installing these sensors, making sure the fire suppression systems work. We got to be aware of it. We got to be aware of our temperature control. So humidity. So we want to control our humidity. We don't want high humidity. Obviously, the moisture can ruin electronic equipment. Fire suppression. So we're going to have gas-based systems, so you can't put water on a Class C fire, an electrical fire. And then temperature control. Obviously, we're going to have a big HVAC system to keep our network equipment cooled off for performance, right? So we're going to have big cooling systems, and the ideal temperature of network rooms, comms closets, data centers should be stable, typically between 64 and 80 degrees. Now, obviously in our cold aisles, it's going to be a lot colder. People that work in data centers usually bring a jacket to work. Okay, now let's go ahead and do our quiz. Okay, so where we left off here, let's go ahead and exit. And let's go ahead to our lessons here. We'll go to domain 2.4.1. And let's take our domain quiz. So question 1. Why is it important to maintain proper humidity levels in a data center network or network room or comms closet? Not to overheat. Low humidity won't freeze them. We're going to go with D here. High humidity can lead to condensation, while low humidity increases the risk of static electricity. Question 2. What is the purpose of a power distribution unit in a network rack? This is going to be B, to distribute electrical power to multiple devices within the rack. Question 3. Which of the following best explains why an UPS is critical in a network installation? It's going to supply temporary power during outages, allowing for safe shutdowns or switching to backup generators. And that is true. Maybe if you don't have a great automatic transfer switch on a generator in your data center, your UPS can hold over until that generator takes over. UPS also have a life cycle, just to let people know. Sometimes they'll have old batteries they've had for 10 to 15 years. You got to replace those. Okay, question 4. Which of the following is a key function of a patch panel in network installation? Patch panel. It's going to be A, to connect and organize network cabling, making it easier to connect devices to the network. Question 5. Why is it important to consider voltage requirements when installing network devices? So this is kind of anything, right? Incorrect voltage can cause damage, right? Can lead to failures, could ruin circuitry. Question 6. Which of the following best describes the function of an IDF, intermediate distribution frame? So we're going to go with B here. It houses smaller networking equipment and connects end user devices to the larger network. Connects them to the MDF, right, which could be our distro core switch, where our server's farm could be. Okay, moving on. Question 7. What is the primary benefit of implementing a hot aisle/cold aisle layout in a data center? It's going to be C. It improves cooling efficiency by separating cold air intake and the hot air exhaust areas. Very common in data centers. We're always going to have something like that, some sort of hot-cold aisle variation. Question 8. What should be a primary consideration when placing an MDF in a building? it's going to be near our ISP, right? Wherever that circuit's coming in at, that's where we want the MDF. So just easier, just for our architecture, our design, right? And obviously in a central data center would be good for secure access. All right, so that's 100%. I want to thank you guys for viewing. Make sure you like and subscribe. If you're interested in getting access to our learning management system, click the links in the description below. Reach out to our team. And thank you for viewing. Stay tuned for our next video, our next section, when we go into Domain 3.